Welcome to episode 21 of Roid Rage. We're legal for drinking, and evidently Robin brought a Capri Sun today because today I learned that company is still in business. All right, we are not going to talk about Capri Suns today. We are going to talk about margins and mass budget.
That's what we're talking about?
Yeah.
We are talking about margins and mass budget. Once again,
Oh
there's a
my God,
script
this
for
is going to be so boring.
Well, to counteract the inherent boringness of margins and mass budget, we have brought on a special guest. His name is Eric.
Yeah, it's still boring though.
You got to get closer to the mic.
gotta get a little bit closer.
I think you are the closest thing that we have on the team to the dude.
Oh
No, to what's the guy? Dumbledore?
Those are wild,
very different people.
Who's the guy in Hogwarts that like lives in the field? Hagrid.
Yes.
That guy. That's what I'm
Yeah.
talking about. Yeah, same guy.
More similar, but still pretty different.
Yeah.
What
you're
the
pretty close.
actual?
But I will
What
say,
does the
like,
matter with you
the
guys?
dude being like the laziest guy in LA County probably works well for you guys. Me working here, being lazy in that regard as well. So you get nothing done from me.
All right. Well, other than
There's
being
got to
lazy,
be a better way for me to spend 45 minutes.
Yeah,
Eric,
machine's
Before-
not running.
before we talk about how you break our machines all the time, why don't you tell people who you are and how you got here?
My name's Eric. Work in structures. Got here after a few other jobs in aerospace.
Okay. Like
and then
what?
was at SpaceX from 2010 to 2015.
Okay.
Virgin Orbit 2017 to 2021.
By the way, just for the record, I don't remember you at all at Virgin.
We did not know each other at Virgin. I knew Robin because he did stuff, but I didn't know you.
Wow. Wow. Eric's available for employment if anybody's listening.
Yeah, after Virgin, did a little stint at a kind of robotics food automation company.
Okay.
And
Is that how
then,
you call it?
yeah, I mean, that's kind of what a little pizza truck company is a pizza truck. They're not around anymore.
What was that called? I forgot.
Stellar Pizza.
Stellar. Are they bankrupt?
I don't know. I think they were purchased by a Korean company. I believe they were purchased, but I have no idea. I don't really know.
Gotcha.
And then yeah, I was unemployed for a little bit, and then came here.
Okay.
Yeah.
All right. You came here and you started to build our structure, and then you probably had to run headlong into this thing called mass budget and margin. Can you explain in layman's terms what that actually means?
Which part, like margins, mass budget, all of it?
Yeah, all of it. Start
Okay.
from the top.
Start
All
from
right.
mass budget. What's
Start
a
with
mass
mass budget. Okay, so we have purchased 200 kilograms to go on a rocket.
Yep.
And so we can't be over that because we'll get kicked off. So we got to stay under that. So every group's got kind of like an allocation of mass that they get to use.
Okay.
I don't know where that allocation came from. Probably Matt. And so we got to stay within those numbers. And yeah, so every group has a set amount, and we've been told to just get it lower and lower every single day. And we're still overweight, I think. So
Because you went over your amount.
very little.
Yeah, the way a mass budget works though is before you build a spacecraft, we knew we had purchased 200 kilograms, right? That's all we had. So what we do is we start to build a spacecraft that is, Jesus Christ.
Sorry.
Okay, time out while Eric figures out how to use a fucking.
Robin moved it. I didn't.
Robin moved it because you were fucking it up.
Well, that made it way worse. All right, let's try this.
Okay, but put the little screen thing in front of the microphone. Rachel, you're gonna have a lot of editing on this one with Eric.
Oh, you're so good.
All right, here we go. Got it.
Perfect.
Go.
Okay, now talk into it.
Talking into the mic.
Okay, Robin, you explain what a mass budget is. I don't even want to talk anymore.
Go, Robin, go.
Mass budgets. So on the you're allocated a mass budget for your particular, different pieces, but the whole spacecraft has to come in under the total mass. So it's not just about structures or propulsion or whatever, right? It's got to have all these different elements that go into it. But kind of the most important part of the mass budget that, if I remember correctly, you've been ignoring is this other word called margin, which is, for design uncertainty. Like, oh, I think this component's going to weigh 2 pounds, except we actually use kilograms. So it turns out it's, 4.4 pounds because it's 2 kilograms.
Yeah.
Yeah, just to confuse you.
Mm-hmm.
Yeah.
Yeah. First job in metric. So that's nice.
I don't know what to say about that. Anyway, so you gotta have margin, because then when you go machine it, or you think it weighs this much in CAD, and then you realize you forgot to use the right mass properties or things like inserts or, I don't know, fasteners.
Yeah, there's going to be a lot of unknown mass that's going to add up pretty quickly.
That's not true. You should totally know the mass, Eric.
Like I said, there's probably going to be a good amount of unknown mass that adds up pretty quickly. But
All
at
right.
the end of the day, we'll get below 200.
So maybe let's ground this a little more. What are you actually working on right now?
Right now, I am attempting to machine the base plate for vestry.
Okay, so Robin came to you some number of days or months ago and said, "Hey, we need a base plate."
Correct.
Did you have a
Wait, what's the base plate again?
That would be the kind of the primary structure that all of the rest of the spacecraft essentially bolts to, and the primary load goes through and then attaches to the rocket.
I'll talk about it in English terms. It's the bottom.
It's a plate on the bottom of the spacecraft.
Sounds important.
It's, it kind of matters.
All right.
It
Okay.
matters.
Is this the thing that drives where we is this the biggest consumer of mass on the spacecraft?
No, the fuel is for sure.
Okay.
Oh, thank God.
Yes. What do we have? I mean,
And
just to
wait,
get a
wait,
rough-
wait, wait. No, it's propellant, not fuel.
That
Fair
is
enough.
true. That is true.
I am not a prop engineer.
To give
I
you
know.
a general breakdown, overall we have 62 kilograms of fuel allocated on the spacecraft.
Propellant.
Fuel, propellant,
Combustibles.
whatever. Combustibles.
No,
No,
it is
actually.
specifically
Yes,
not
no, it's not.
I was
combustible.
gonna say, even
Not
I
at
knew it
all.
wasn't combustible.
Oh, man.
It's xenon propellant on the spacecraft. The primary structure was allocated how many kgs? Which is the box, essentially, the base plate and all the panels on it. Dude, you're building the primary structure
my
and you don't know
God.
how much you're fucking allocated?
No, I'm just trying to make it as light as possible. And then I look at the mass budget spreadsheet every once in a while. I'm like, yeah, I'm below that number. That number's a little bit off, but
so
I'll
you know, it
update
was
that.
allocated 20 kilograms of the total budget.
Okay, cool.
The wings were allocated 12 kilograms, and all the little wings are 12. The avionics boxes are 11 apiece.
Seems like you guys are disagreeing here. Do you guys know?
No, I'm adding up in my head. You thought the base plate was going to weigh 20 kilograms?
No, the whole primary structure.
Oh, primary structure.
Primary
Okay.
structure.
Yeah.
The
We're
base
back.
plate is
We're simpatico. Okay.
and
I
then
was like,
everything else kind of
no way
adds
we
up.
make it.
Reaction wheels, thrusters, all that kind of stuff gets tacked on and is accounted for. But at different levels, we know different accuracies. So like our batteries, for example, they're pretty heavy, but we can measure them. We actually have them. So we just put them on a scale and know exactly how much they weigh. The base plate probably has the biggest ambiguity to it because it is not done. And it is
Correct.
one of the most complicated machining parts we have to make. The rest of the primary structure is just panels that we cut.
So this
Correct.
So this is really your lunch break because the base plate's not done and you're in here
Correct. And the machine is not running.
and the machine is not running.
Why
So
is the machine not running?
Well, because we've run it through all the programs that we have.
Okay.
Yeah.
yeah, we'll have a performance improvement plan a little bit later.
Yeah. Something about like programming ahead of time.
That'll be the next show.
Yeah.
Pips.
Yeah, let's do that. Next episode's on pips.
Coming back for Pips. Coming back for Pips. First guest for Pips. All right.
All right. Who creates mass budgets?
I think Matt made our mass budget up. I looked at it and was like, yeah, that's not going to work. So then I edited it.
Yeah,
That
this
is
is why I didn't look at it
absolutely
that
not
much.
true.
Like, this is
First
why I
off,
didn't even look at
the
it that
only
much.
thing I did
Like,
was
what are we
I
talking about?
bought 200 kilograms. I was
Yeah.
like, yeah, our spacecraft's going to
Yeah,
weigh under
that's-
200 kilograms, bought it.
And everyone just has the direction, make shit as light as possible.
No,
No,
that
they
is
don't.
not
Eric.
true.
That is actually not
Okay,
true. But also,
so what you do is you grab some of these different design reference guidelines on other spacecraft, and you go through and you can look at what the percentage is on different kinds of systems allocating within the spacecraft.
Okay.
So that's kind of like a first initial pass at a system engineering level. I know we don't like to use that term, but we'll let it go. And that's a first pass. And then once you get some conceptual designs and some idea of the different payloads and the way that you're designing the spacecraft, you go back and refine those numbers. So you start out with on the order of like a 20% reserve on mass. So you actually try to design a spacecraft that's like, in our case, let's call it 180 kilograms to make sure that you come under
that's a
200
10%
kilograms.
reserve.
Yeah,
but,
it is, but it's hard.
So it'd be 160 kilograms.
Yeah, yeah. Like I said, 180 kilograms.
I know that math is hard.
Yeah, it's super hard. And then as you figure out problems or you need to add things.
I just feel crowded by this mic.
What do you
going,
feel
keep
crowded by
going.
them? Are you claustrophobic of a microphone?
It's just like,
Well,
It's
you
like,
keep
it's
going
like
on.
in front of your face so you could talk into it?
yeah, no, just keep going. In your
you
mass
literally
budget
have
thing.
it like up at your forehead.
You adjusted it.
No, Rachel adjusted it.
Don't blame Rachel for your mistakes.
This might be one of our top 10 worst guests.
That's cool.
It's equally the guest and the host in this space. It feels like that's No, never mind. I take that back.
I'm just
No,
gonna
it's
I'm just gonna watch Eric move his mic around. All right. Well, anyway, so you get the idea, and you have different uncertainties that you apply to, as Matt was starting to say.
The microphone is slowly falling
Is this
down.
like the faulty arm?
Rachel, can you please help Eric?
Can we
figure
get
out
some
how to,
structural
Hold
engineers
on, we
in the room?
trust this dude to make a base plate and he can't even make an adjustable mic?
No mechanisms. By the way, we're leaving this part in. We're not even cutting
absolutely.
it out.
Oh, yeah,
Why
for
did
sure.
you guys get like the cheapest mic stands?
Rachel,
No, this is Josh.
Josh also didn't know how to stick styrofoam to the wall, so.
But clearly, this is not just a me problem. This is a mic stand problem.
Here, wait.
Yeah, there we go.
Oh, look at that.
Now you can't drink any water, so now you'll be
Water
thirsting
bottle
to death
Or the
in this
wind,
hot-ass room.
except that it's now pointed up at your forehead.
That's why I'm a closer.
Yep.
All right, here we go.
So when you're at that, like, oh, I looked it up in SMAD level, and it's 20% or whatever. And then once you have some conceptual designs in CAD, you can lower that down to whatever, 10%. And then once you've actually made some parts, or maybe you get a quote out of a vendor, you go down to like 5%. Now, why isn't that 0% at that point, right? Like what? And it's because you still haven't been through the testing of the spacecraft, so you don't know like what little late additions that you're going to need on the spacecraft to like make sure it passes vibe or TVAC or whatever other testing is going on. So you always have to have a little bit of reserve.
Yep.
And we don't right now, but we're working on it.
And there's certain that applies differently to different things. For instance, in order to get the delta V we need, there is no mass margin on fuel. We load fuel by weight, right? So we're loading 62 kilograms of propellant, fuel, whatever, onto the spacecraft. And it doesn't matter. Like that has zero margin on it because we load by that.
because it's combustible.
Because of the combustible
And we're
fuel.
going to combust all of it.
We're going to combust it
What?
all.
Are you tired? This is not combustible. Cut it out.
What's next, chap? That's all I got.
Oh, I think you're going wrong.
You like the world's worst moderator. Whatever.
I like that you still think that there's moderating of you. It's just a gentle
Worst
redirection.
episode so far.
All right.
Have the other ones been good?
They've been better than this.
Yeah, better than you know.
yeah.
We
No, I'm glad there's
takes
some good ones out there.
It takes a while to
Yeah.
find the natural flow of the conversation. All right. So
This
you
one's
get
taking
told-
about the whole episode.
You get told you need to make a base plate. You're making
Yeah.
a base plate right now.
Correct.
You theoretically have a target weight for this base plate.
Yeah, about 4.3 kilos.
4.3 kilos. Okay. Where do you start?
With what? Making it?
Yeah.
What
do you mean?
Oh my god!
Yeah. Where do you start?
What the fuck you think he's asking?
Well, I mean, it's a pretty big
what'd you
question.
start
Where do
in
you
life?
start? Like,
What'd you
start
do?
with like the program?
Eric's like, "I get out of bed every day.
Put my shoes on. Well, you got to get some stock. Select the material. Pick what material you want. So we're using aluminum 7075.
Okay.
We're picking that over 6061 because of its higher strength and stiffness properties.
What about stress corrosion cracking?
We are, we're not like cycling that much. We're not cycling that much. I don't think it's as big of a concern for us.
I got to tell you, you're not really convincing. I just have to take another action
Yeah.
and go look at our
Yeah,
life
but
cycle.
yeah.
Fatigue.
I don't think it's an
property.
issue.
Yeah, I think it's fine.
How long is ascent? What's our frequency and kind of like what do those curves look like for the cycle on high fatigue for that? I think we're pretty good.
Aren't you supposed to look at that? Why are you asking us?
It's a rhetorical question.
Oh,
Like we're fine. So we select the material, then the design goes over into a CAM program to
Why
kind
don't
of
we just
generate
use
the tool
steel?
path.
Isn't steel cheaper?
hold on. You skipped a whole bunch of steps. What do you mean the design? What design?
I think you missed
Well, I think the
quarter
question
two
was,
this
I missed
year,
that
actually.
question, which is
I
how
thought
do you
the question-
design a base plate?
No, I thought the question was you're asked to start making it, so how do you make it? That's what I asked. What do you
man.
mean? But where are we making it or designing it?
Designing.
So start with the design. We got to design before we make, right?
Well, sometimes.
Sort of.
Okay.
Yeah, because we made a few before the design was done. Some
I mean,
Why'd
a
you do
few
that?
is an understatement.
we made a few
And
that are
design
not.
is done is also an overstatement.
Yeah, the design's still not done.
Did you know what they did, Robin? Though there was so many iterations that they just changed the way they numbered the base plates.
What?
Yeah,
Well, also, I mean, what do you count an iteration? Every time I hit save?
I mean,
Oh, jeez. This is the worst episode ever.
There is like 20
it's
iterations.
like we're like
but-
interviewing a hostile witness here.
but
Good
like-
God, man.
But yeah, there's like 20
Look,
iterations.
you get
but
some
yeah.
requirements, one of which is mass. And you come up with some concepts,
All right,
and then
look,
we
we
flush
have-
it down the toilet,
We have
and
like a
then you put it in
configuration of what the
CAD.
thing's supposed to take with it, like batteries, reaction wheels,
Yep.
etc. Where does it go? Where do we want them to be? How does it interface to the plate? Where do they need to be thermally connected to each other versus the panels versus the plate? And then we can kind of start to lay things out. We can look at some basic numbers as far as how much force is going to go into it based on how much mass we have where and what the accelerations are of the rocket. And we can kind of see at what point is it going to be a problem or not a problem. From a simple level, we can kind of look at some of the different stiffnesses and kind of play with the different levers that have the biggest effect on those. So for like a standard plate, messing with the height kind of gets us the most out of stiffness for that structure itself.
Okay.
So we can take some initial
Would that
approaches
be
like
because of its increased moment of inertia?
that would be.
Okay, just checking.
Yeah. That would be because of I.
Ooh,
Yeah.
capital I,
Capital I. And
not
then,
lowercase I. That'd be
capital-
imaginary.
Yeah, capital E also comes into play a lot. That would be the material stiffness, not the geometric stiffness. So that kind of goes back to the 70-75 over the 60-61. So at this point, the rest of the team is kind of figuring out what are the different components, where do they go? And so none of this stuff is really defined when the design for a base plate starts. I mean, I think we changed batteries at like version 12 of the base plate.
Okay.
That had a kind of a different form factor a little bit. We went from a 4 to a 5.
We never changed the batteries.
There was a different battery in box, I'll tell you that.
No, I
much.
just told you to move 'em.
Sounds like the design spiral. I think we had an episode on it.
We did. Yeah.
Oh, wait. I'm sorry. You are right.
I'm
Hey,
never
we could
wrong.
put
The
a
vendor-
we could
the
put a
vendor
link
gave us
to
the-
the
they
other
gave the-
episode.
The
Like
vendor gave us the
when
wrong
I talk,
data
it just
pack
takes
for
you
the
there
4
because
kilowatt, not
this
the 5
episode
kilowatt.
sucks.
But then we did change reaction wheels. And so all of that is kind of as iterations have already been taking place. So kind of back to your question about why so many iterations of the base plate, a lot of different components were changing, a lot of different things were changing. And so
But as an overall design philosophy, what we were trying to do with the base plate, right, is there's a 24-inch ring that we mount to on the rocket.
Ooh, that sounds like an important requirement.
It kind of was, I think, Eric. Did you capture that one?
we got
We got
that.
the ring in there. Okay,
Yeah, we got the
24
ring.
So we
inch.
get the right number of bolts.
We got all 36 of them.
Okay, so we got 36 bolts on a 24-inch S spring. That's how we mount to the rocket. And really, what we want to do is mount everything as close to that ring as possible, so we don't have giant lever arms off the base plate. So making everything compact and small is a really, really big challenge on a very small, lightweight plate.
Yeah. The integration team's not going to have a great time with it just because of how packaged it is with harnessing, prop lines, components.
Wait. You're
everything.
telling me you did not design for manufacturability and assembly?
To an extent.
Aren't you a
but-
manufacturing engineer?
Yeah, but it's a small space. That's a lot of stuff.
Hmm.
It's still going to suck.
So how many times did I tell you to make the base plate smaller?
I don't know, 8, 9, something like that.
At what point is this in the design? Is this after you've actually gone down to the machine and like made one? Like, when do you get the feedback from them?
Well, no, we made the first one or the first attempt back in April.
You mean the door?
The square one.
Yeah, the door.
Yeah, the square isogrid, just square.
Is that the one I just laughed at you and walked away?
Yeah, that's pretty much what we both were like. What is this?
That was probably that one.
Yeah.
Yeah. So then, so that turned into more of a circle.
What did that weigh? Do you remember?
No,
I do.
You'd like to forget, huh?
8.5 kilograms.
8.5 kilograms, folks.
8.5.
I will
Is
never
that-
forget.
Is that with it? My math is rusty sometimes. Is that within 10% of 4.4?
No.
No. Okay.
No.
Cool. Just checking.
yeah, it's pretty far off.
Or 20%.
Okay.
So then
we
you
just iterated
iterated.
from there.
Yeah.
Did a few iterations.
Or redesigns, whatever you want to call them.
It's
So,
the same
so you've
file.
pretty much got the base plate design process nailed down. Like I could just basically like go into your computer and say, Chat GPT, please repeat Eric.
We would hope so, but I mean, let's see how it does in vibes.
Oh, sorry. I said repeat, not replace.
I'd use Grok. A little bit
Really?
better. Yeah.
Make it an angry base plate.
Oh, we might, but you take that risk.
Would it be lighter? I'd take angry if it was lighter.
I don't know if it'll be lighter. It's gonna have some baggage.
All right. So it was 8.5 kilograms.
Was the first one.
And what is where are we at right now on the plate that you're currently a month late machining?
We think like 4.3. 4.3.
We think.
Well, it's not done.
How far into the build are you?
Wait, what happened to the 4.2 version?
Yeah, I was wondering that too. How did it get, especially when you keep hitting it with the drill bit and putting excess holes in it? How come it's not wider than 4.3?
Well,
Is it the extra drill bits that are now embedded in it?
it's not the extra drill bits. It's the additional fillets and some additional material.
Eric's
for
just gonna
some
rage
peak
quit on this
stresses.
podcast.
It's yeah. No, it's
Well,
not
I mean,
the holes. It's, not
it's
the drill
either he
bits.
rage quits on this one or gets pipped on the next one, whichever.
That'd be a good one.
Yeah, we never did a live pip with somebody on the pod.
That would be
Eric, we
awesome.
brought you here to talk to
Bring
you.
them in on
Crystal would not allow that.
Let's just put on a pip.
I haven't done that before, but I'm just gonna take a wild guess and say that's a bad idea.
I'm down to try it. You never know until you try.
Fair enough.
We have to make that our first live episode too, like
Yeah,
just straight on.
But no. So to answer your question, there were some peak stresses in some areas, so we added some material. And then when doing the design and iterating and analysis, we don't add all of the fillets or all of the features. Coming back and adding that slowly adds some grams here and there.
It's
But
also
yeah.
been good to go manufacture it. So this will be, I think honestly, this is the 4th or 5th base plate we've actually put through the machine. Is it the 5th? And the reason that's a good thing to do and not looked at as a bad thing to do is we get a lot better understanding of how to manufacture the base plate.
Yeah, including the programming that's associated and like, oh, how are we going to flip it over? When's the right time to do this?
How
Like,
do we anchor it down?
kind of all kidding aside, we're ribbing you a hard time, giving you a hard time and ribbing you, but like,
Look, we should also point out I'm not a machinist.
you are
now.
today.
What are you talking about?
You are, yeah. Relative to everybody else right now, you are.
Yeah, let's be clear. We bought this machine in January, and I'd never used one before. So
Hey,
it's
Matt.
going well. It's going well.
By the way, we bought it before January. It just arrived in January.
Yeah, and that also sounds like an excuse.
Yeah.
Everybody comes to start.
Fair
I
enough.
like to wear multiple hats, and then when you wear them, you're like, oh, I don't want to be a
it's really
machinist.
hard.
Oh
I
no,
don't
it's a
wanna
lot
wear
of
the
fun.
hard
It's
hat.
really great, but like, this is kind of what you get from it.
But also,
You might
going
also
through-
get a staph infection.
You might also get a staph infection. That coolant can be bad.
Did you get
gotta-
a staph infection?
No, it's just possible. Like the coolant in the
This took
machine.
a left turn. What do you mean? What?
Yeah, you got to explain this one. I'm missing a step between
Like
coolant.
cool?
and the
Yeah,
staph
like I'm sure
infection.
if you inject
That's my job on the
coolant into your body, it's
on the
probably not good.
podcast, just to totally derail whatever
all right.
conversation.
When the machine showed up, whoever ordered it, when the machine showed, there's two types. When the machine showed up, it showed up with coolant, which is for the machine. That coolant was not antibacterial coolant. There is antibacterial coolant, which we now use, but the original coolant that showed up with the machine was not.
That
So-
sounds like an upsell.
So we now have antibacterial coolant, and we have a thing in the machine that actively disinfects and cleans the coolant to keep it clean to prevent things like
Hold on.
staph bacterial growth in
Why?
the coolant.
Why is that like a real thing? What?
Yeah, no, it's
It's
just
a
a
real
real
thing.
thing. Because you're gonna get coolant on you, and like it's always warm. It's exactly the right temperature to grow things that you don't want to grow. And
You're
so if you
reaching
don't
in there,
do it,
grabbing
you're gonna
metal,
get
sharp
sick.
edges, etc. You get cuts on your
yeah,
hand.
it's super
Yeah.
bad. It's a real thing.
So you're working in a petri dish is a basically.
Yeah.
At exactly the right temperature.
Yeah.
And like the room, the temperature this room is becoming is sort of like the shop floor. And so, yeah, like Robin said, just petri dish for bacteria.
Good to know. I didn't know that was a real thing. So how much did that cost us?
That doesn't matter.
The coolant's not, I mean, it's just a different type of coolant.
I'm just
It's not
trying to
that
balance. Like
expensive.
we always got to ask the question: is it more expensive to
Than
get the
a staph
antibacterial
infection?
coolant, or
Way
no,
cheaper.
for Eric to get a staph infection, not me or you? How much does that cost me? And I'm not sure. Is that under OSHA or workers' comp?
I don't know.
I would frame this differently if he's the only one who's the machinist right now.
Again, not a machinist.
So we knew we were gonna make some models.
Well, so
And we weren't really worried about it being flight right away because we wanted to learn things.
Oh, yeah, we knew
how,
those
how
first
small
plates
can we
were
make
not
those
flight.
radii
Yeah.
and is this material gonna like move on us as we're machining it? What's the right order? So otherwise,
Probably
it's
going to run the
bowed.
back of the jig into the back of the machine and hit the little
Again.
grooves and have to fix them overnight by
Yeah.
driving and going and getting just
Yeah,
theoretically.
Yeah, just regular
and,
stuff.
and then get
Yeah.
yelled at for not like doing lockout, tag out procedure
Yeah.
on the machine.
That
Just
kinda stuff.
as
Yeah.
a random,
Yeah.
non-specific
Hypothetically.
example.
random aside.
Or allegedly.
Yeah.
Allegedly.
Yeah.
Yeah.
We should probably use that word a little bit more on this podcast.
Allegedly.
Yeah.
Yeah.
Allegedly.
Come on,
Anyway,
say it,
what
Matt.
do
Then
we
we
do?
got 4.
I'm not doing it.
Oh.
But yeah, I think the base plate that is currently on.
Wait,
the
but how do
machine-
you know the base plate like is going to work?
Well, so that's what I thought we were first going to talk about when it said margins on the Notion page.
Yeah, yeah.
But yeah, so working closely with Holly, we're iterating on designs and building.
Who's Holly?
She's one of the other structures engineers on the team.
Have we had her on this podcast?
We have not.
Why did we pick Eric over Holly?
That's a good question.
Because she's busy.
Oh, she's doing real work.
Yeah, the machine's not running.
Yeah.
I'm not busy.
Excuses.
So anyway, working closely with Holly, the two of us are iterating on the design, doing like component level analysis and then assembly level analysis at different levels of fidelity to kind of see where the base plate is potentially not stiff enough or not strong enough.
How does she do that?
Well, you can take a CAD model.
Never mind. I'm going to ask her. How do you do it?
Yeah. How do I do it?
Yeah.
Okay. Take a CAD model.
That's really hoping it's gonna be like, I just draw it on a piece of paper.
Well, I mean, if you're talking from the very beginning, you can start with like top level hand calcs and just like initial.
We do a lot of
There
hand
you go.
calcs. But I mean, even
Hand
But
today,
hey,
calcs.
we're getting.
we do a lot.
I think you're talking like at a certain point, the geometry gets pretty complex, and you actually want to get into the computer assisted. Helps you with the math.
Engineering.
Yeah.
But the hand calcs are important to understand, just the basic understanding of where to put stuff. And I mean, we did a lot of hand calcs at multiple times and reoriented the whole base plate. I mean, what was that weekend we came in and
Bloody
flipped
Sunday.
the whole thing, right? And like made it all different. I'm pretty sure you're about ready to rage quit, but you didn't. You're still here. I'm sorry. But I mean, it's important to understand those hand calcs because it helps us optimize for the design before we just get into this mode of like, let's run it in through a CAD model and get an output. It also helps us check the outputs. We've had a couple mistakes in CAD models that when you look at it from a hand calc standpoint or just from a high level standpoint are pretty easy to identify if you are looking correctly for them.
Yeah, I mean, so that's how we help validate the analysis from the computer. So we had, one of the outputs of the modal analysis talked about how much deflection was going to happen in the center of the base plate. So we were able to do a very just basic like I-beam calculation, thinking of like what is that lever arm, how much of that mass is that, distribute that roughly about how many ribs go to the center, like what is the thickness of the ribs, the height of the ribs, and then you're able to kind of, this is hugely simplified, but you're able to bound the answer from the computer and see that this is within the ballpark and within the range of what we're doing on hand calculations in a grossly simplified version. So that then, validates some of the output from the higher fidelity.
So you've got a design, you've got analysis to think it works. You've validated your analysis by hand, calcs, and then you've gone off and machined it or remachined it or re-machined it, whatever the case is. And then what?
Well, then we're going to do some fit checks. We're going to measure it, inspect it, make sure it's actually what we think it's supposed to be. We're going to put some coatings on it to protect it from some corrosion and at the same time, make sure we still have some good electrical contact.
Well, before we do any of that, how are you going to get your drill bits out of it?
I'm going to use other drill bits to drill those out.
So that everybody understands, Eric broke 2 drill bits now?
2 drill bits.
2
So
drill
far.
bits in small holes, yeah.
2
So
drill
far.
bits are stuck in the plate.
So far.
No, it's okay. Today we had all the smaller holes are drilled and tapped today, so those are.
So far.
Are the little drill bits out or are they still in there?
No, I've ignored those. For
So
now.
all the holes aren't drilled and tapped then as well?
Well, the smaller ones are drilled and tapped.
Aren't those ones small?
The ones that broke are 160. The ones that were drilled and tapped today are 120. So I broke the bigger ones, not the smaller ones.
Okay.
Yeah.
So you fix your drill bits. What are you doing after?
Then I'm going to re-drill those holes. And then at that point, the part's almost done. Deburr it, clean it up, get rid of sharp edges, have it inspected. We have some equipment for very basic inspections, but we'll send it out to out of house for a proper full inspection. And then we're sending it off for coating, for corrosion protection.
What coating do we put on it?
For this, we're just going to use iodine.
Are we doing any anodization?
Like a hard anodize? No, we're just going to go with an iodine, which is kind of like not a hard anodize. I don't know.
It is
Observation,
It's like-
Eric.
It is not a type 3 anodized,
Yeah.
nor is it a type 2 anodized.
Yeah.
Hey, so if you don't anodize it, it's not like an anodize?
No, it's not. If you don't use anodized, then you haven't anodized it. So we're
Never
going to
realized
iodine
that.
it instead.
Yeah.
But type 2 is a pretty common one. But that's not appropriate for this part.
Why not?
Well, we want good electrical contact between the various parts. So the iodine gives that to us.
Yeah, sure. But usually on a spacecraft, you'll mask and tape the holes, right? So you have electrical connection and then coat. So why are we not coating it?
Well, that sounds like a lot of extra work to mask a lot of different holes and features when we don't need it.
And why don't we need type 2 anodized or type 3?
I like this because I don't think Eric knows the answer, but we're gonna keep hounding him on it until he gives us a valid
All
answer.
right,
Or he gets it wrong, we cut
he
it
gets
out
it
and,
wrong,
give,
and we
and then
can
we
make
give
fun
him
of
the
him for
answer
getting
and
it
then he
wrong.
gives the
Yeah.
right one. Yeah. So the audience will never know if he knew it or
This
No,
not.
they'll
is
know.
the
We're
last
leaving this
episode
in.
with an employee on it. And they're all like, fuck no.
let's do anodized. Pop quiz time. Type 3 anodized is a thicker one, typically used for mechanical, like for when there's a lot of wear and contact between surfaces. So you want a harder type 3, thicker anodized so it doesn't break down and come off. Type 2 is just thinner, not as thick. It's not as robust, it's not as wear resistant, but it's pretty much the standard for everything when you don't need that wear resistance and robustness.
And you can get it in colors.
And you can get it in colors, which is pretty cool.
Yep.
Yeah. I think is type
That's
3
all you care about is the color?
I mean,
It's
yeah,
type-
how sick would that be to have like a branded base plate? I was gonna get it 3 colors: the orange, black, and white.
Do you have any idea how expensive it is to get a custom color?
The orange is not custom; it's orderable.
Oh, so we're just gonna like use their Pantone color as our logo.
Pantone orange.
How did you come
logo.
up with orange for AstroForge? Oh, it's the same as the
The one
anodized.
that we can get on the anodized base plate that no one will ever see.
It's called style, guys.
Yeah.
and it doesn't even need to be anodized.
Yeah.
I'm sorry I took us down the anodization rabbit
No.
hole. So you get this plate with anodized, it's assembled like
Aldehyde.
excuse me,
That's okay.
Aldehyde.
Yeah.
Thank you for
We
the
don't- we don't wanna
correction.
get the- We don't want to get the wrong
Put
thing
that
on
in the
there.
pip.
Yeah. Interrupts his boss
Correcting Robin.
on a podcast.
I mean, that's got to be a bonus. That goes in the plus column right away.
Yeah.
I mean, but I guess what I was looking for is how do you know that your hand calcs and analysis were right and that like this thing is actually going to survive? Like it's going to do its job.
Yeah, we're gonna test it. We're gonna test the actual hardware.
Oh,
So
tell me more.
let's talk about testing. So the test that we're going into, the main one that the structures team is preparing for is a structures vibe test. So that would not be all of the flight hardware, but it would essentially be a flight base plate. Same design, same machining program, same material. All of the rest of the primary structure would be the same. But instead of putting the very expensive other components, batteries, flight computers, tanks, etc., we just have mass simulators, things that represent the same mass in ideally the same CG for each component, so that the mass is distributed exactly correctly. And then we'll go to a test house, get on a shaker table, and just shake the hell out of that thing based on the loads, based on the inputs and requirements that we have from SpaceX, and see how it does. And then we'll, obviously have a bunch of instrumentation on it so we can get results. And
There you go.
see what
Sorry,
happens.
I was going to
Were you
see
just
how
were you just waiting for the word instrumentation?
Yeah, I was because you're like, see how it does. I'm like,
just a
there's a slightly bit more quantitative way
No,
that we
it's all
do that
just
versus
visual inspection.
the qualitative. Like,
But the
know.
good news is next week we're going to actually have a podcast that talks about how we do that test and integration.
God, who's that with?
Wesley?
It's gonna be boring.
All right, chap. We got any other questions? What are we doing here?
I think we've talked. I mean, is there anything else we haven't talked about when it comes to how you think about margins and mass budget?
Oh man, now you're putting me on the spot.
That's the whole point. Of
I mean,
having you
it
as a
is
guest.
literally a podcast. Like,
Yeah.
you want us to like give you a homework assignment? Like,
What did you want?
Well, hold on. Let's just put it this way. You guys are my bosses and told me to come on a podcast. I can't exactly say no, right?
I guess he's right.
I mean, yeah, he's
yeah,
right. but
yeah, kind of.
Yeah.
You still
So I'm here.
we also ask you to do work. You still could do better.
This is fair. This is true.
We're not paying him for this hour. This is his lunch break.
Yeah.
Also true.
Now that you're a machinist, you're paid hourly. We lowered your pay, by the way. And this is your lunch break.
Do I get overtime though?
No.
Yeah.
No, he is most definitely not hourly. He's a self-directed employee, which we give tasks that we expect him.
non-exempt, right? Non-exempt,
Is this
self-directed.
a legal coverage statement right now?
I think it's actually exempt.
Whatever, you're one of those.
Yeah, you're either exempt or non-exempt.
We don't actually
Thanks,
know.
Matt. The,
All right,
the
what
answer
else-
is
what
zero
else
or
do we
some
know
other
about mass
number.
budgets.
Well, so right now we have a focus on getting the base plate machine and sent off to for integration of some of the propellant stuff, propulsion stuff. But the other thing that's at the forefront of some of our minds and structures is that not everything is designed. So we have panels and other primary structure that is designed well enough so we could put load into the base plate and distribute that load and see how the base plate reacts and what our modes are and what stresses we see. But we also know that when it comes to some of the other structure on the spacecraft, the same level of detail that we're doing to the panel, we have to then do to those items. And so there's still, Robin was talking about percentage of uncertainty.
Mhm.
There's higher uncertainty on other primary structure components that haven't been worked through to the extent that the baseplate has. So there's still some unknown there. So it's a concern. Robin's not pleased.
No, I'm very displeased.
Yeah. But I mean, you knew those things aren't
But it's,
fully designed yet.
yeah, isn't that part of the design spiral we talked about earlier?
Yeah, it is, except that the design spiral is supposed to be like coming.
Spiraling.
Yeah, it's supposed to
Yeah.
be spiraling
We're
in,
just in the
not
design
out.
circle?
Yeah, we're just
Okay.
not
What's
not
the,
closing.
What's the inverse of a spiral?
Well, spiraling out instead
Spiraling
of in.
out. Yeah.
Yeah.
Okay.
And Eric's got to take our spacecraft on a diet here. I'm literally going to go out there with a drill and be like, "Hey, Holly, can I drill like right?" Oh no, too late.
We had discussed that.
Yeah.
Yeah. Just putting holes in it, just Swiss cheesing it.
Yeah.
Yeah.
Okay.
We're going to get it under 4.
Under 4?
Oh yeah.
Yeah, it's easy to get under 4.
It's easy to get under 4. It's not easy to get under 4 and have it survive.
It's easy. I bet you me and Robin could do it within a week.
I would gladly take that bet and have this podcast again in a week to see who can machine the better base plate.
Oh yeah, that includes machining, right?
Oh, you didn't machine it in a week.
You haven't machined it in a month and a half.
In fact, you haven't machined it yet.
That's true. But I haven't scrapped one yet either.
Well, that's debatable.
No,
You see
that's
the
fact.
giant worm
Well.
on the side of this one?
Well, we'll see when you're done getting the bits
Yeah,
out.
I'm not done, knock on wood, but I have not scrapped one yet.
Knock on aluminum.
All right. You get to ask these 2 questions. So
Oh, I did not approve this segment.
that's all right.
I am
approved
not
it.
down with this.
What questions?
Pit for chat.
What questions do you have for Matt and Robin or me?
Yeah, why
Yeah,
weren't you
wait.
in there? Yeah.
Or
Rachel.
in a business organization, what the hell is a chief of staff?
Wow. I like this segment. This is a good segment.
I love it.
In a business organization, the real answer is it's somebody who's good at a lot of things. You just throw a bunch of shit at, and you hope that they can do it.
Junk drawer.
Gotcha. Okay.
That's the question. And moving on to
Mailbag.
All right, cool. If you all have questions for them, I'll give you time at the end, but we'll move to mailbag. All right, this one's for you. This is from Anurag. Sorry. What are the driving
You said for you.
constraints?
Who's you? There's 3 of us. Eric.
What are the driving constraints of how strong the primary structure has to be when it comes to actually mining the asteroid? What are some of the most stressful parts of mining?
I would say
You know
most
we video record as well, right? Like just saying.
Yeah, see all the GoPros?
I mean, as far as I'm concerned, the most stressful part of mining is landing on the asteroid, but I know that's not mining, so it's kind of a non-answer.
I feel like that's a reasonable answer.
I mean, let's just be honest. The most stressful part of mining is the launch. Like, what are you talking about? Landing is way less
Actually,
stressful.
the most
than
stressful
launch.
part of mining is getting the budget to buy this
Yeah.
stuff for the spacecraft.
I'm pretty sure he meant this from a primary structure perspective.
Oh,
Wait, you mean this from
I got it.
stressful loads or stressful
Yeah.
mentally?
I mean,
But
okay,
let's
I
say
guess
stressful
it-
loads. Everything's stressful mentally.
Loads. Okay. Well, let's go with loads.
No, I mean our driving load cases by a lot is going to be launched on the rocket. I mean, what our landing? We're supposed to be coming into land at a meter per second.
Maximum. That's
Maximum.
the upper end.
yeah,
supposed
we
to be
want to
much-
be way less.
Way more gentle than that.
Yeah.
So like obviously from a primary structure standpoint, it doesn't matter at all. No, I mean launch is by
So
far
you're saying we could actually shave some weight off?
no, because we still have to launch.
Post-launch.
Yes, we can shave weight off post launch. Yes.
We could do staging.
Yeah.
Stage the primary structure.
I don't know how that would work, but I'm here for it.
But I would be concerned about things like the solar arrays not flopping over like crazy when we come down and land, and we actually continue generating power when we're on the asteroid.
This is typical primary structure guy where they're like, I'm actually concerned with everybody else,
Yeah,
like
yeah.
the secondary structures.
Yeah. Because
Yeah.
if the primary structure gets through vibe at protocol levels, I am not concerned at all.
Okay.
Yeah.
I also like that the primary structure guy is not worried about a metric ton of material coming back in his structure and surviving a crash?
Not at all.
Okay.
Because that's not vestry.
Yes, it is. He just doesn't know yet.
You didn't
All
get
right.
the updated requirements memo,
I did
huh?
not. I did
Moving
not.
on, and Eric, this is another one for you. This is
Oh,
from
this is
Ben.
great.
The important part about this question is Ben actually listened to a Roid Rage landing podcast. And so he has another question about landing. He wants to know, why don't we just use a harpoon? Using harpoon to stay attached to the magnetic feet for stabilization seems feasible when you're on the surface. So to clarify, I think he's implying that we land, clamp with our feet, and then harpoon into the asteroid.
But if
Fuck
we're
yeah.
already on the asteroid, why would we harpoon into it again?
Don't
Because
ask the real
harpoons
questions.
are cool.
Harpoons are awesome. Why
Harp-
wouldn't you use a harpoon?
Yeah. Why aren't we harpooning a metal asteroid?
I'm going to go onto Amazon and buy some crossbows right
That's
now.
a fair question. Let's add harpoons.
Then we
Okay.
could be like real
What-
pirates.
Just ballpark. What do you think that mass budget is?
For the harpoon?
Yeah.
Oh, we can probably get like another 40 kilos just for the harpoon.
Okay.
Just for the harpoon.
Okay.
I mean, we could actually go harpoon fishing and just call them asteroids and go shoot fish all day
True.
on your boat.
Yeah, thanks for the parking spot, by the way.
Yeah, you're welcome.
The bill is still coming.
No,
That's
that's storage.
all right. And this one, last one from Rohan. Do you see the downmass capabilities?
Hold on, does this guy work here or no?
I declined to answer that question.
Wow. Wow.
Do you see the downmass capabilities from launch providers like Stoke being an advantage for your business? Many companies are putting a lot of efforts into the downmass problem, such as Varda, and this seems to be non-trivial.
I mean, the honest truth is, no. Stoke is building a reentry vehicle for stage 2. It is not meant to return satellite vehicles. And for us, again, there isn't. I think this is a misconception of a lot of people. Is in order for us to take advantage of something like a Varda capsule or a Stoke reentry, we have to be in low Earth orbit. I do not have the Delta V or the fuel, not the propellant, the fuel on the spacecraft, to slow down enough to get into low Earth orbit. And so we
Not
actually
that
could
attitude.
not mount to any of these to do it. We have to do from deep space coming in at a high velocity directly into the atmosphere to slow down.
And how fast is that again?
12,000 kilometers a second, miles per hour, hours per kilometer.
Sorry, I just had to.
There's some ratio of kilometers and hours. I don't know. It's 12,000 something. I think it's 12,000 kilometers an hour is what we come in at, right? Is that right? No? What is it, Robin? What is it? You tell me.
It's 11 kilometers a second.
11 kilometers a second, which is I'm pretty close.
11,000 kilometers an hour is pretty close to 11.
No, I said 12,000. And yeah, don't fact check me.
Okay, fine.
All right. Eric, last chance. Any questions for these two?
Robin, why'd you come do this?
Podcast?
No, like work here at AstroForge. You weren't you like chilling happily, like not working and relaxing for a while, and then you came and worked for this guy? Like, why'd you come do this?
Clearly a lapse in judgment.
There's another pip.
No, okay. Real answer. My career, I have been very fortunate in my career to be part of some really amazing teams. And as I started looking for what to do next, I really like being on the edge of what is actually physically possible. Like it's been done before, right? So we've launched Psyche, we've done OSIRIS-REx, we've done Hayabusa. I probably mispronounced that.
Hayabusa.
Hayabusa.
Hayabusa. Thanks.
see.
Extra letter in there. Yeah. Anyway, so we know as a species and as a nation that it is possible to build spacecraft that go to near Earth objects and asteroids, and then return material from them. That is physically totally possible. But to do so, adding on like in an economical, repeatable way, that's a challenge, right? So that's pretty much the space that I like to be in my career is like, oh, it's possible, but really, really hard. And so that's what really interested me about coming to mine asteroids. Oh yeah, that, and I totally need a real excuse to get a Expanse OPA tattoo on my neck. And the only way I can do that is by working for an asteroid mining company.
Okay.
That was a hard left and neck tat.
Matt, what's
Sick.
your tag gonna be?
What's my tat going to be?
Yeah.
Tat.
Is it a neck tattoo specifically or just any tattoo?
Dude, if I get a neck tattoo, he needs to get a neck tattoo.
If
I have
like,
no tattoos and I don't plan on getting any
if
tattoos.
Vestry performs
No
like
commitment.
exceptionally well,
Uh-huh.
I don't know what exactly that
If
means yet.
Vestry hits all the mission objectives,
You have
I
to get a
will
tattoo.
do no celebration and worry about the next mission.
How about you get a face tattoo?
If we, on the next mission, so 2 in a row, if we go and mine an asteroid and bring it back, I will get dollar bills under my eyeballs.
Okay, wait. So this means
Whoa,
hold on.
okay. Hang on. let me understand this correctly.
We need to define
I
success.
really hope someone makes it to this point in the podcast because this is absurd.
So let's define success criteria here.
So I just want to say I have worked with a CEO who promised to get a tattoo with me when we were successful. So they're going to remain nameless, and the tattoo bet is going to remain vague, so that hopefully someday can ask somebody can do a mailbag question. But for you, what I'm understanding is, if on mission 4 we are able to successfully launch, navigate, rendezvous with, land on an asteroid, collect some amount of material from the asteroid, return to Earth with that sample, you will get tattoos of dollar signs underneath your eyeballs on your face.
Yes.
All right.
Wow.
Yep. And I'm going to get them like jailhouse tats too. Not even good.
You can't say that.
Why not?
I think the most baffling part of this is that you went from I'm getting no tattoos to making what might be one of the worst tattoo choices of all time.
That's why I got to get it on the record.
Yeah, I appreciate it. Like I was here for you to clear. Like it's very crystal.
If you're going to go for it, go for it,
So
right?
we're-
Like,
so
Wait. Permanent
Yeah.
tattoos.
Yeah, none of this tennis shit.
whatever.
Okay. I missed an important word there. Okay.
Because that's
Well,
the point when like I'll be rich enough where what I look like doesn't matter.
So we're either out of business or you're getting face tattoos.
Yes.
Yeah.
I think both are not, those are not mutually exclusive.
They actually aren't.
Yes.
Can you imagine that? We bring it back. We fail as a company that has that big dollar signs under my eyeballs. Like,
All right.
guess I'm just homeless.
Let's get off the air.
This feels like a wrap. Today
Yeah.
we learned a lot of things. We learned maybe about mass budgets and margins. Undetermined. We learned.
Well, we learned that the primary structural base plate is 4.3 kilograms, which is 0.3 kilograms over its allocated mass budget on a 200 kilogram spacecraft.
Yep.
Kind of amazing how light these things are for the amount of load they take.
Yeah. And we also learned that Matt has terrible taste in tattoos.
Nobody
but,
makes
like,
it this far on the podcast. It doesn't matter.
we're gonna.
How many
Rachel,
people listen to this? Like,
please,
are you able to
Rachel, how many people listen
please
to the
Easter
last
egg title
episode?
this so that people make it.
250 people, Eric. So that's pretty much not that many.
250 people listen
Yeah.
to this.
Yeah.
Keeping in mind, we have almost 50 people that work here.
It's
So
like,
But
okay.
I would make a bet that
Each
less
with
than a quarter
one
of
or
our
two parents.
less than a quarter of our team listens to this.
I don't listen to this.
I have not listened to one.
I
Yeah.
would make a bet that less than a quarter of the population of the 250 make it this far into the podcast.
So if you want to design the dollar signs, please send us designs.
Hey,
to
did we give
mailbag
that guy
at
the
AstroForge.io.
T-shirt?
I believe we responded, and it should be in the mail.
Rachel?
Rachel?
I responded to them, but I'm waiting for us to get like our actual shirts to send.
So that sounds
Okay.
like a no.
Okay.
So it's
No,
not,
send him one of the
Wait,
shitty ones. He
it's
called me out.
it's not Matt's sweaty T-shirt?
No, I don't mean the shitty ones that you made. I mean the shitty ones we have from before.
Oh yeah.
What'd you get called out on?
They're fine.
I don't know. Somebody said I was wrong, and that's
Chap
clearly
is
not
trying
true.
so hard. He's like, I'm out,
Matt
man.
was wrong.
No, I was not.
That's
I was
the only
misquoted.
takeaway. He wasn't misquoted.
I'm
He was
literally
wrong.
going to buy T-shirts for the entire company that say Matt was wrong.
All right, that's a wrap. We got to the end of this. There's no more room here. Thank you for listening to us, and we'll see you next week.